Hey guys, hope all is well. Hopefully week one went okay. If you're struggling a bit, hopefully within the next week you'll find a routine that works for you. Just don't give up, keep pushing. Everyone's having a little grace for you. So don't worry about making things perfect, just try your hardest. This recording is going to be of section 11.2. Some of it should be review for you. Other stuff will be new. A lot of the new stuff is similar to what section 11.1. So hopefully it won't be that hard. All right, so we always start with vocab. Population density, you guys hear about this a lot, especially on the news. Population density is just a measure of how many people live within a given area. Okay, so with like marketing and politics, you hear a lot about population density. I think with coronavirus right now, New York City's getting hit super hard. Well, that's because they have a very high population density. I looked the other day and I think it's something like 67,000 people per square mile. Something crazy like that. I don't know. That could be totally inaccurate, but I believe that's what I read. Sector of a circle. It's the region bounded by two radii of a circle and its intercepted arc. Remember, radii is just plural for radius. So if we were to draw a sector of a circle, here's my center. If I have one radius here, another radius here, the intercepted arc would be this around it. And therefore the sector would be this entire thing right in here. Think of it like a piece of the pie or something like that. Area, you guys should already be accustomed to area. It's just the amount of space inside the boundary of a two-dimensional figure. So when it's two-dimensional, that means we're going to use units squared. So inches squared, feet squared, miles squared, whatever. All right, area of a circle, guys, pi r squared. Hopefully, you guys have done some of this in the past. Hopefully, most of you may probably even know that equation by heart. So let's do a couple of examples. The area of a circle with a radius of 9 inches. Okay, so area is just pi r squared. So my area is just going to be pi times 9 squared. Now, if I simplify that, this square only goes to the radius. We don't apply that to the pi 2. We don't square pi. So area is just, well, 9 squared is 81. So we'll just say 81 pi, and that would be in inches squared. So this would be our answer. If Big Ideas had something like this and they asked you to put it in as a decimal, all you do is put 81 pi into your calculator and then round it however way Big Ideas wants you to. The radius of a circle now, it gives you that the area is 100. Okay, so 100 is the area. That's going to equal pi r squared. And now I just want to find r. So to do that, we just do algebra. Divide both sides by pi. 100 over pi is roughly 31.83. That gives us r squared. Don't forget the square. We want r by itself, so undo a square. We take the square root, and I get r is roughly 5.64, and that is what? Miles. All right, the next one we have to do a little bit more work, but it's not hard work. It's very doable work. So here I want to find the area of a circle with the circumference of 12. Okay, when I look up at my area formula, all I need to find the area is the radius. Well, it doesn't give me the radius, all it gives me is the circumference, but I can use the circumference to find the radius and then use the radius to find the area. So let's do that. So first we want to find the radius. So circumference equals 2 pi r. Sorry, my sleeve hit the board. This thing is touchy. Okay. That's the equation of circumference. Well, it tells us the circumference is 12. So I would just put 12 in for circumference. Now remember, pi is not a variable, pi is a number. So to get r by itself, let's divide by 2 pi, divide by 2 pi. Guys, remember when I'm putting this in my calculator, make sure you put the denominator in parentheses. You will get an incorrect answer if you don't. So when I put 12 divided by 2 pi, my calculator, I get R is roughly 1.9-ish. That's rounded. Okay, that's not my answer, but I can use that to get to my answer. Okay, now I want to find the area of this circle. So A equals pi r squared. Well, my R is 1.9. And remember, I square only my 1.9. I don't square my R or my pi. So when I put this into my calculator, I get roughly 11.34, and that would be centimeters squared. Hopefully all that makes sense to you guys. All right, area of sector. Okay, this is very similar to when we found the arc length in 11.1. So to find the area of the sector, basically all I'm doing is I want to find the area of this shaded region. Okay, so just like arc length, the area of the, I'm just going to put A sub S so I don't have to write it all out, is going to equal the proportion times the entire area. And then if I want to break that down a little more, the area of the sector is going to equal, well, to find the proportion, that's just the central angle over 360 times the area is pi r squared. So we're going to use that for these next examples. All right, this top example here, I want to find the area of both the pink and the blue sector. So let's do the pink one first. Okay, so to find the area of the shaded pink region here, I would just do the area of the sector is going to equal the proportion, and the proportion is the central angle, which is 70 over 360, times the entire area, which is pi times, my radius is 8 squared. If we put that all in my calculator, guys, you should get the area of the sector of the pink sector is roughly, I should have put roughly squiggly lines, 39.1, and that is in inches squared. All right, now let's do the blue sector. Blue sector, same concept, so blue. Okay, I still want area of the sector equals the proportion. Well, guys, if this is 70, all the way around is 360, this has to be 360 minus 70. So the central angle there would be 290 over 360 to get the proportion, times the area of the circle, which is still pi times 8 squared. If you put that all into your calculator, you get A is roughly 162, and that would be in inches squared. All right, here's one kind of the same but different. What we have and what we're trying to find are two different things. So find the area of circle B. So we want the area of the entire circle. Okay, what we're given is, this is the area of the sector. This is the area of the pink sector. We want to find the area of the entire circle, pink and blue. All right, so the area of the circle is pi r squared. The area of a sector is the proportion times pi r squared. All right, well, we have to start with the area of the sector. So the sector equals the proportion times the area. Straight from a couple slides ago, or maybe just one slide ago. All right, well, area of the sector we know is 35. So 35 is going to equal, my proportion is the central angle over 360 times my area is pi r squared, but I can just keep it as A if I want to. And I'll show you why. So here I have 35 equals 1 over 9 times A. And in order to get A by itself, I'm going to multiply both sides by 9. There we go. I'm going to cross out that A, which gives me the area is 315 meters squared. All right, next example. We have a rectangular wall that has an entrance cut into it. So the blue here is the wall. And then here is, I don't know, looks like a doorway to me. We want to paint the wall. So when we paint the wall, clearly we don't need to paint the doorway.
I'm paying attention.
Oh, okay. When you paint the wall, you don't need to paint the doorway. And if you guys have ever been with your parents when they buy paint, paint is not cheap. It is very expensive. So you don't want to buy 1,000,000 gallons when you only need 2. But then again, if you don't have enough paint, to match paint is very, very difficult. So if we don't have enough paint, we could have the same wall be in 2 different shades of blue. So I want to find the area of this wall here. So what I'm going to do is I'm going to take the area of the entire wall, and I'm going to subtract the area of the doorway, or whatever way is cut into it. Okay, so the area of the entire thing, notice this is just a rectangle here. So it's just well, the bottom is 36 times this here is 26. So to find the area of this whole thing, it's just 26 times 36, and that is going to equal 936. Okay, now to find the doorway. Well, if you look, this doorway is made up from 2 shapes. We have the rectangle on bottom, and then we have like this semicircle type thing on top. Okay, so let's do the bottom rectangle first. So the rectangle on bottom, guys, I just noticed this is definitely not drawn to scale. This is 16, so this would be 16. The height of it right here is also 16. So to find the area of this, it'd be 16 times 16, which is 256. Now the semicircle. All right, so this is just a half circle. Think of it as a half circle. We know the whole diameter is 16 here, but all we care about is the radius. So the radius is 8. So once again, this is just a half circle. So to find the area, I'm going to take 1/2 times pi r squared. And when you do that, you get the area is roughly, I don't know, 100.53. So to find the area of the shaded region, you're going to take the wall, so 936, minus the doorway, which is the combination of this here and this semicircle. And when I put that into my calculator, I get roughly or about 579.47, and that would be feet squared. There we have it. All right, guys, one more example, or I guess kind of 2 along the same thing. Population density. Like I said, you hear of population density a lot. Right now, you're hearing it a lot with coronavirus. The more populated area we have, the more it seems to spread, which should make sense. You use it a lot for marketing. When you're marketing a certain thing, you don't want to market a place that has a low population density because you're paying the same. So you want to get it out to as many people as you can. You hear it a lot in politics when they talk about, oh, Virginia has a population density of whatever, they're voting whatever. You hear of it a lot. You probably don't notice it, but if you start listening for it, I'm sure you will hear it. All right, so the first example, about 430 people live within a 5-mile radius of the city's town hall. Find the population density in people per square mile. Well, population density, guys, it's number of people over the area of the land. Okay, so this is clearly the number of people. Okay, well, this 5-mile radius, this is not the area of the land, but we could find the area of the land by pi r squared. Think of a radius, that tells you you're dealing with a circle. So the area of this is pi times 5 squared. So 25 pi, which is roughly 78.54. All right, so that is just the area. So if we want to find the population density, that's going to equal the number of people, which is 430,000, divided by the area, which is 78.54, and you get roughly 5475, and that'd be people per mile squared. And that would be your answer. All right, last one. We'll call it a lesson. All right, a region with a 3-mile radius, guys. Okay, well, I'm going to do the same thing. I'm going to find the area. If I know it has, the radius of 3, I can find the area by pi times 3 squared. So that's just 9 pi. If I put that into my calculator, that's roughly 28.3 miles squared. So keep that in mind. All right, a region with 3-mile radius or with an area of 28.3 has a population density, it tells us the population density, guys, of 6195 people per square mile. So we're still going to use the same formula, it's just what we know is in a different spot. So the population density is 6195. So 6195 equals the number of people, which we don't know, that's what we're trying to find, over the area of land, which is 28.3. Now we're just here, we have an algebra problem. So let's multiply both sides by 28.3, 28.3, 28.3 times 6195, you get roughly 175,159 people or persons or whatever. All right, that is it for 11.2. My algebra 2 is on 7.2. That's it for 11.2. Hope you guys are doing okay. Please, 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 if you're having problems, shoot me an email and I will help you out in any way I can. Don't feel like you're alone and you don't have any help. Talk to you guys next time.